Bismillahirrahmanirrahim. Last time we have discussed the grouped frequency distribution. As we mentioned before, the statistic is just the sign that conduct study or collect the data, organize, summarize, and analyze the data. And we spoke about the collecting the data and organizing the data. And we said that we have two types of frequency distribution: the categorical frequency distribution and the grouped frequency distribution. In this part, we are going to speak about the graphing the data after we organize or after we constructed the frequency distribution. This will be the next step in this series. And we have three types of a graph for today. We have more than three, but today we are going to speak about the three types of a graph for the frequency distributions. The first one is the histogram. And second one is the frequency polygon, and the third one is the Ogive. Let's start with the histogram. Histogram it is a graph that displays the data by using continuous vertical bars of various height to represent the frequencies of the classes. So it's just a continuous, and we have to focus on this one. Continuous vertical bars, because we have another type of a graph that which it is not continuous. So the histogram is just a continuous bar graph that show the height or the frequencies of the group or any group data. We are going to speak about the group data. For example, this example was discussed last time, and we formed the frequency distribution. Now we need to construct or draw the histogram for this frequency distribution. We have 30 students, and we need to construct the frequency distribution. It is already done since from the last time. In this part, we need to graph the histogram. For the histogram, is a graph that I have x-axis and y-axis, or vertical axis and horizontal axis. In the vertical one, we need to set the frequencies. The horizontal one will be the classes. And the frequency distribution given there started with 45.5 or 44.5. This should be 44.5. We are going to use the class boundaries, not the class limits, because we need to form continuous histogram. Because the class limits will give me some limits or the classes, but there is a gap between 52 and 53, 60 and 61. So these are not continuous, so I'm not going to use the class limits. We need to use class boundaries. Starting with 44.5. Next one is 52.5. We have 60.5, 68.5. We have 76.5. We have 84.5, and the last one is 100.5. So we need to add more. and last one is 100.5. These are the class boundaries. You have to be careful. We are using class boundaries. Now for the frequencies, go back. Start, the lowest one is 1, the highest one is 9. So we can use one step frequency. Because if we have large number, we can use 2 steps or 5 steps in each one, or the scale is divided by 5 or by 3, depending on the highest value in the frequency. But since the highest value in this example is 9, so it is easy to set the frequency using the 1. So this is 1, 2, 3, 4, 5, 6. The height is not enough. This smaller scale, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. You see the frequency of the first class. It is 1. So we are going to graph a bar for the first class. And the height is equal to 1. This is the height. Because the frequency for this class is equal to 1. Second one is 4. I'm going to graph up to 4. Okay, it should be 4, not 5. So this is the second bar. Third one, when the third class has frequency equal to 5, next one is 4. So the third one is 5. Next one is 4. Next one is 9. Nice. So this is the frequency for the next one, and then we have 5 and 2. 5. And the last one is 2. So this is the histogram for the group, or for this table given in this example, the group frequency distribution. So the idea is to set the class boundaries on the horizontal axis, and the frequency is on the vertical axis. Then we graph a vertical line showing the height or the frequencies for each one. Take another example. Let me see this one. We are given the group the frequency distribution, and we need to draw a histogram for this one. This also done last time. In the last part, we constructed this grouped frequency distribution. Now we need to graph the histogram. Same thing. So vertical axis and horizontal one. For the horizontal one, we with the class boundaries, starting with 746.5. Again, this should be 45, not 46. There's a mistake in this one. 745. So we mentioned that to form the class boundaries, we deduct 0.5 from the lower limit and add 0.5 to the upper limit. So the first one should be 745.5. 745.5. Next one is we're adding 6 is 751. Next one will be 757.5. Next one will be 763.5. Next one is 769.5. Next one is 776.5. And then we have 780. This should be 75. 1.5. For the frequencies, see, we have from 2 to 7. The highest one is 7. So I can use 2-step scale. So this will be 1, 2, 3, 4, 5, 6, 7. The highest one is 7. Now the frequency for the first class, it is 4. I have 4, 4, 7, 7, 6, 2. So the first two are 4. So this is 4. This is the first one. Second one also. We have 4. The height for the second one is 4. The next one is 7 and 7. So it is 7, 4. For the next two classes. Next one, we have 6. So this should be there. The height is 6. And the last one is 2. So this is the histogram for this example. And you can see all the bars are touching each other, or we have continuous graph. The histogram must be continuous graph or continuous vertical bars, and this shows the classes and the frequencies of the classes. The height of the bar is the frequency of each class. And it must be continuous, and that's why we are using the class boundaries. Next type of the figure is the frequency polygon. The frequency polygon is a graph that displays the data by using lines that connect points voted for the frequency at the middle point of the classes. For the frequency polygon, we need to find the midpoint for each class. For example, in this example, which is the frequencies just taken from the last example. We need to draw a frequency polygon. In the last part, in the last example, we graphed the histogram. Now, I'm going to use the same example, but to graph a frequency polygon. For the frequency polygon, we have to find the midpoint for each class. The midpoint can be found by adding the lower limit, upper limit, or the lower boundary plus the upper boundary. Lower plus upper boundary divided by 2. For example, in the first one, this is equal to 7, 40, it was 45, not 46. 45.5, sorry, say this is a mistake, plus 7, 51.5 divided by 2. Add the lower boundary plus the upper boundary and divide by 2. This will give me the midpoint for the class. So using the calculator for this one, I think the difference is only 6. It's very easy to find. 745.5 plus 751.5 divided by 2 will be 748.5. Should be 748.5. I can do this for each one of the classes, or I just simply add the class width, which is equal to 6 in this example. So we can add 6 each time. So next one will be 754.5. Next one will be 760.5. Next one will be 7, just add 6. That will be 66.5. Next one will be 772.5, and next one will be 778.5. So we need just to find the midpoint of the classes. Now the frequency polygon, for this one, we are going to put the midpoint. And this is as it is its frequencies. So we have the polygon and frequencies. The first midpoint was 748.5. 748.5. Next one was 7.5. Next one was 760. One was 766.5, then 772.5, and last one was 778.5. Frequencies start with, say, 2 scale is okay. So it is 1, 2, 3, 4, 5, 6, and 7, because the highest one is equal to 7. Now I have 4, 4, 7, 7, 6, 2. The frequencies. First one should be exactly at the midpoint of the classes. So this is 4. Next one is 4. Next one we have 7. Then we have also 7. Should be at the midpoint for each one. Next one was 6. And last one was 2. This is 2. Now we need to connect this point using just lines or line segments. Just connect between these points. The first one, second one, third one. So it is polygon. So this is the polygon frequency, but we have to be careful about one thing. For the frequency polygon, we have to close it. It means we have to start with the zero frequency and end with the zero frequency. So we must have closed part. So this one should go for this point, and last one should go for this point. Now, what are these points? The closing point. The first one is just the midpoint of the class before the first one. Let me call it zero class. So this point, it will be 742.5, just minus 6, the class width, to close the frequency polygon. For the last one, we add 6, so it will be this point, should be 784.5. I can call them virtual midpoints because this will be the external midpoint from the less than the first class and larger than the last class. So we can call them the virtual or the zero frequencies classes. These are not part of the classes, but I have to add them at the beginning and at the end of the group, the frequency distribution, just to close the polygon. We have to close the polygon. That's why I need to add one more. This is just for closing. 784.5 and give it 0. And one up, that will be 742.5 and also give it 0 frequency. These are just to close the polygon frequency. For the Ogive. Ogive is a graph that represents the cumulative frequencies for the classes in a frequency distribution. See what I mean by cumulative frequencies first. Let's take this example. The ages for 25 students in statistics class are shown. Construct the frequency distribution, and this will be the frequency distribution, and also construct cumulative frequency distribution. For this data, as I mentioned before, the range is equal to the highest minus the lowest. Highest age is 23, minus the lowest is 19 is equal to 4. So you can see the range for the data is very small. It's only 4. And that's why we are not using grouped frequency distribution or grouped classes, because the range is very small. This is small. If we have a small range, we use like categorical, not grouped. I have only few items I can list them. And these are 19, 20, 21, 22, 23. But if we use this one, 19, 20, you can see there is a gap between 19 and 20. So we are going to use class boundaries for each one. So 19 is between 18.5 and 19.5. Next one will be the 20, which is between 19.5 to 20.5. Next one is 20.5 to 21.5, and next one is 21.5 to 22.5, and next one is 22.5 to 23.5. Frequencies are found to be 5, 11, 5, 3, and 1. Now, we need to construct cumulative frequency. Cumulative frequency. See the first column. I will take the lowest limit. I will start with that limit to say less than 18.5. And you can see in the data there is no age less than 18.5, so it is 0. Next one, take 19.5. So we are moving in this way. We are taking the lower limits plus the last one in the first column. So it is less than 18.5, less than 19.5, less than 20.5, 20.5, 22.5, and 23.5. Now for the frequencies, we started with 0. Now we are going to add. Next step, 0 plus 5 is equal to 5. Now we are adding. So less than 19.5, it is 5. Less than 20.5, it means the first two frequencies. We are adding 5 plus 11, which is equal to 16. We add these two. Next one, we are going to add to the third frequency. It will be 16 plus 5. So less than 21.5 is 16 plus 5 is equal to 21. This is less than 21.5. Next one, less than 22.5. Add one more, add 3. So it's 21 plus 3 is equal to 24. Less than 23.5 equal to 25. So this will be the last one, is the total number of the students. It is 25. Now we can, okay, this one we call it cumulative or accumulative. Distribution. So the idea now is to put the class boundaries, which is 18.5, 19.5, 20.5, 21.5, 22.5, and 23.5. And we have up to 25. So I can use 5 and 5 scales. That will be to cover the highest one, 20 and 25. Highest one is 25. So I will use 5 steps or 5-step scale. First one, 0. Next one is 5. Next one is 16. This point. Then we have 21 point, this 21, which will be about this point. Then next one we have 24. And last one is 25. So the Ogive starts with 0. This graph is called the Ogive. And again, for the Ogive, we need to use the accumulative frequency distribution. We adding the frequencies for each step start with 0, then add it to the next one. For the next class, we add the next one, and then the next one, up to the last one. And this will give me the Ogive for the given frequency distribution. So we have discussed the 3 types of graphs in this part. The histogram, when we are using continuous vertical bars, using on the horizontal axis the class boundaries, and for the vertical axis we are using the frequencies. The second one was the frequency polygon, where we need to find the midpoints for each class, then we graph the frequency polygon, and also we have to add two midpoints, the first one and the last one, or virtual midpoints. And the last one was the Ogive, where we need to use the accumulated frequency distribution.